FreeCAD is one of the few truly free and open source computer-aided design packages out there. It's capable of creating complex designs, but it's not without some bugs and pitfalls. In this 10-part series, I'm going to help you get up to speed with FreeCAD so you can start designing your own parts. Before we jump into the specifics of using the program, I want to talk about why you should use FreeCAD and cases where something else might be better. Let's get started. Here is the syllabus for the course. In this episode, I'll talk about the pros and cons of using FreeCAD over other CAD packages. I'll end with installing FreeCAD and giving a tour of the interface to help you understand the layout and where to find things. Next, we'll dive into the basics of creating an object using the Part Design Workbench. This workbench relies on the more modern paradigm of creating features from sketches. We'll then talk about creating designs that interface two separate bodies in the same document. Even though you can use FreeCAD for designing just about any mechanical part, I'll assume that you're mostly interested in using it to make custom 3D printed parts. As a result, I'll show you how to design for and use heat set inserts, as they are incredibly popular for holding 3D printed pieces together. After that, we'll look at creating patterns from features and using Boolean operations to fuse or cut parts to create more complex shapes. Revolutions, pipes, and lofts can make it easy to create other complex shapes. Up to this point, we'll focus mostly on the Part Design Workbench in FreeCAD. While it's a great way to get started making most basic and intermediate shapes, it has some limitations when it comes to creating curved surfaces. As a result, we'll need to look at the Curved Shapes Workbench, which is a third-party add-on that makes working with lofts along guide rails much easier. We'll also look at the Curves Workbench for doing organic shapes. Finally, we'll examine the Assemblies Workbench to see how parts fit together, and then the Finite Element Method, or FEM Workbench, for simulating stress and failure points on designs. As I mentioned, much of this series assumes you'll be interested in designing parts for 3D printing. Because of that, I'll 3D print most of the parts you see in this series so you can see how they come out. If you have access to a printer, you are also welcome to print the parts, as seeing them come to life in the physical world is always inspiring. If you do not have access to a printer, that's okay too. You can still follow along with the series to learn how to use FreeCAD, which is great for even non-3D printed designs. I like to learn a little bit about the history of tools I'm using and compare it to other tools on the market. But if you're not interested, feel free to skip ahead to the part where we install the software, or to the next episode where I'll show you how to design a part. The history of computer-aided design is almost as old as the electronic computer itself. In the 1950s, computer scientist Douglas Ross coined the term CAD to describe using interactive graphical displays inspired by radar equipment to help debug software and display flowcharts and circuit diagrams. Then, in 1964, DAC-1 was released, which was one of the earliest forms of commercial CAD programs. Patrick Hanratty, a lead developer on DAC-1, is often considered to be the father of CAD. By some accounts, 70% of all 3D mechanical CAD software today can trace their roots back to Hanratty's code. Lots happened in 30 years to further the state of commercial CAD. But let's shift our focus to FreeCAD. In 1993, Matra Data Vision, a French company, released the computer-aided software for computer-aided design and engineering, or Cascade, which provided the foundational layer for the Euclid CAD package. Around the time Matra Data Vision was acquired by Dassault Systèmes in 1999, they open-sourced Cascade, as I suppose it wasn't needed for Dassault's SolidWorks. Jürgen Riegel, who was working for Daimler in 2001 and had been building software on top of OpenCascade, started working on an open-source CAD software that he called FreeCAD. His colleague, Werner Meyer, joined him as soon as the project was announced. Together, they released the very first version of FreeCAD in 2002. A few years later, Jörg von Haver joined the team. From there, we see the Sketcher Workbench added in version 0.10 and the Part Design Workbench added in version 0.11. While FreeCAD consists of many different workbenches, as we'll see later, these are the two most important ones that you'll interact with regularly, especially as you're learning the software. In 2015, Jurgen left the core team and is no longer active on the project. Then, in 2019, Abdullah, Bernd, Sliptonic, and Wanderer Fan joined the core dev team. And here we are today in 2024. While the development version of FreeCAD is 0.22, it will likely become the first official version 1.0 release. Along with that, the community submitted various logos for a brand refresh, and this new modern logo by Sebastian Tabares was chosen. While this is all well and good, why should you even consider using FreeCAD over other CAD packages? The reality is that, like Linux, a free and open source CAD package has its advantages and disadvantages. On one hand, it's free to use and you have complete ownership of all your work, even for commercial purposes. On the other hand, it's not as fully featured nor as intuitive as most commercial packages, and it's prone to crashing. Before we dive into evaluating a few different CAD packages, we need to understand what parametric modeling is. Most 3D CAD programs consist of combining or defining shapes to create one or more complex solids. With direct modeling, you define shapes and dimensions quickly without worrying about constraints or how they'll affect things down the road. Parametric modeling, on the other hand, involves specifying parameters for constraints and dimensions. These might be dimensions on a sketch, on a shape, or defined elsewhere in, say, a spreadsheet. You can then reference these parameters to set exact constraints elsewhere. Also, most modern CAD software will let you update parameters you set earlier, and it will simply update the design without hopefully breaking everything. With that in mind, we'll evaluate these programs using 6 basic criteria. And note that this data was collected in August of 2024 when I recorded this video. The first is cost for personal use, which means it can be used for hobby and educational purposes. With commercial tools, there is usually a limit on how much money you can make from something designed with their free or low-cost version. It's often around $2,000 per year. We'll also look at the minimum cost for going to the commercial version that lets you actually start a business using the tool. This won't include any optional add-ons or additional seats for the license, but most commercial licenses unlock additional features. We'll see if the package can handle parametric modeling or if it relies on direct modeling. I'll also mention open source here, as it's an important aspect of FreeCAD. Open source usually means that the program is developed by a community of programmers, may or may not have funding, and you can expect certain things, like the interface might not be that great and the software might not be super stable. However, it means that you can read and modify the code, and it's usually easier to submit bugs to the core dev team. Next is what operating systems the software runs on and if it runs locally or in the cloud. Finally, we have the number of features and how easy it is to use the software. Both of these are incredibly subjective based on my limited use of the application and stuff I read on the internet, so take it with a grain of salt. First up is FreeCAD, which we'll use as our standard. It's completely open source and free to use even for commercial purposes. It'll run on modern versions of Windows, Mac OS, and Linux. It's actually a fairly complete 3D CAD package with enough features to do complex designs. However, the interface is not particularly intuitive and the error messages can be less than helpful. Next up is the industry standard, SolidWorks. They have a personal version that costs $48 per year, which is not bad. However, if you want to make any significant money off your designs, you'll need to pay for the fully featured commercial version, which starts at around $4,000 plus an annual subscription of about $1,500. Obviously, it's not open source, but it can do parametric modeling. Oh, and it's Windows only. The program runs locally, and you have the option of saving files to their cloud storage system. SolidWorks is the juggernaut in the industry and has just about every feature you can think of, including advanced assembly, simulation, and manufacturing workflows. It's easier to use than FreeCAD, but it still has a pretty steep learning curve. Solid Edge is another commercial CAD package that competes directly with SolidWorks. They have a free community edition, and their basic subscription is about $1,000 per year with a wide range of possible add-ons. Otherwise, it competes almost exactly with SolidWorks. It's Windows only, runs locally, and offers optional cloud storage. I don't have experience with it, but people claim it's similar to SolidWorks in the amount of features and ease of use. From my understanding, it's not as popular as SolidWorks though. Next, we have Autodesk Fusion, which was previously called Fusion 360. This is probably the most popular mechanical CAD package among hobbyists right now. They have a free version for personal use, and the commercial version is $680 per year, which is honestly very reasonable for what you get. It also supports parametric modeling, is closed source, and can run on Windows and Mac OS. Sorry, no Linux. Feature-wise, it's close to what SolidWorks can do in terms of modeling, but it lacks a few advanced simulation workflows. The program runs locally, but you're forced to save your work in the cloud. You can export your data to local files if needed. It's also praised for being intuitive with a lower learning curve than both FreeCAD and SolidWorks. TinkerCAD is another Autodesk product that aims to make 3D modeling easy for mostly educational purposes. It's completely free, but the terms of service claim that Autodesk can use your work in any way they want, which includes sub-licensing it to make money. By default, TinkerCAD is built around a direct modeling paradigm, but recent additions now allow you to define constraints with code blocks scripts, making it somewhat parametric. TinkerCAD is closed source and runs in the cloud, which means you just need an operating system that supports a modern browser. It really only has one basic workflow for modeling shapes by combining simple shapes like cubes and spheres. If you need more advanced features, Autodesk would prefer if you move to something like Fusion. It is, however, extremely easy to use. I think I learned TinkerCAD in about 2 hours. While it's great for educational purposes, you're probably better off with one of the other, more professional tools for complex work. Then we have Onshape, which is a relatively new player on the scene. Like Fusion, they have a free version, but all your projects are made public in the cloud, which means anyone can see and access them. PTC, the company behind Onshape, has rights to use your public projects, much like how Autodesk can use your projects from TinkerCAD. The commercial version starts at $1,500 per year. It supports parametric modeling, is closed source, and runs in the cloud. While I haven't personally used Onshape, most people say it has almost the same amount of features as Fusion and is about as intuitive. To close out this comparison, let's look at 2 other popular open source offerings. First is Blender, which gets a lot of attention in the animation and video game world. The workflow in Blender is organic and better suited for things like animating a 3D character. It's more like sculpting, and people use it a lot for creating models and miniatures that can be 3D printed. So while it's free, it's not really parametric without some third-party add-ons. Like FreeCAD, it's also open source and runs on most of the popular operating systems. There's no cloud option either. While Blender is feature-rich, most of its features are for character design and animation, which don't apply to most of our mechanical needs. The interface has gotten much better than when I tried it many years ago, but the learning curve is still pretty steep. Finally, there's OpenSCAD, which is a parametric modeling software used for making mechanical parts. However, the workflow is completely different from other CAD packages, as it uses a programming language to define the parts. This scripting aspect makes it fully parametric. Like Blender and FreeCAD, it's free and runs locally on most major operating systems. You can do a lot with it, but considering you can run OpenSCAD in FreeCAD as a plugin, I'll say FreeCAD has more features. It can be difficult to learn as you need to know how to program. If you're comfortable programming and learning new scripting languages, feel free to add a couple of stars for ease of use. There are many more CAD programs out there that I did not list, as I mostly focused on the popular ones I hear about in my engineering and hobbyist circles. As you can probably guess, FreeCAD is a perfectly capable parametric modeling application, but it's lacking some of the advanced features of paid tools. The learning curve can also be a bit steeper. However, it's free and you own all of your work. The development team has also made significant improvements in the last couple of years, which puts it in a good position to compete with other paid tools. The biggest improvement has probably been fixing, or at least mitigating, the topological naming problem. This is an issue in almost all modern parametric CAD programs. When you create a shape or feature, the program will assign unique names to all the points, edges, and faces to that feature. We'll create a few features stacked on top of each other. Don't worry about trying to follow along right now. I'm just going to demonstrate this error. Notice that this is FreeCAD version 0.21, which I won't be showing in the rest of the series. Now, if we change one of the earlier features within the same bounds, say making this rectangle a little bigger, the model updates without a problem. However, if we go over the border, FreeCAD needs to make new edges and faces on the underside to make this model work. As a result, the modeling solver breaks. You either end up with the topmost feature on some face you didn't intend, or you get the dreaded recompute failed message. FreeCAD doesn't have the most helpful error messages, and this doesn't tell me what failed. With experience and understanding the sub-icons in the tree view, I know that my model broke sometime around pad 002. To fix this, you'd have to go back to earlier steps and redraw everything. I wasted many hours trying to work around the topological naming problem. Most modern parametric CAD programs have also fixed or at least mitigated this problem. The latest version of FreeCAD, 0.22, which will likely become the official 1.0 release, includes a fix for the topological naming problem. It's not a complete fix, as I still run into issues sometimes, but it's much better than before. Now, when I try to modify the middle sketch, the model does not break like before. Because of this, I'll be showing version 0.22 and recommend that you use it. If you use a later version, that's okay too. Just note that some of the tools or buttons might be in different places or have different names and icons. I'll be using the latest weekly build. My hope is that version 1.0 is released when this video comes out, and you can just use that. But know that version 0.22 should be close enough. I recommend some optional tools if you want to get the most out of this series. The first is a set of calipers, which are useful for taking precise measurements of objects that we want to replicate or interface with. Next is a 3D printer. You don't need one, but most of the videos in this course focus on modeling objects that you can then easily print. There's something fun about actually holding the physical object you designed. I highly recommend checking out my Introduction to 3D Printing videos if you'd like to get started using a 3D printer. I hope that this has helped you understand why you might consider using FreeCAD over paid options, or why you might need to go with a paid CAD package instead. If you still want to learn FreeCAD, I'll show you where to download the latest build and how to navigate in the rest of the episode. In the next episode, we'll design our first part. Head to freecad.org, which has gotten a nice makeover in the past couple of months. Click on Download. Assuming you're using one of the popular operating systems, you can download the installer from this page. If not, well, FreeCAD is open source, and you can always build it from source code. When I filmed this, version 0.21 was still the official release. By the time you watch this video, I'm hoping that these installers will be for version 1.0. Note that some of the features you see in this series might be a little different, or the icons might change. If these links are not for version 1.0 or later, then you'll want to run one of the weekly builds. Scroll down and click on the weekly builds link. Find the package for your operating system and download it. That's Windows for me. Unzip it somewhere on your computer. This might take some time. For Mac and Linux, you might need to run an installer. When that's done, navigate into the FreeCAD folder and find the bin folder. In there, find the FreeCAD executable. Feel free to make a shortcut to this file somewhere on your desktop or start bar. For now, just double-click it to start FreeCAD. Once again, this process is probably different for Mac and Linux, but it should be equally straightforward. If Windows yells at you that the app is unrecognized, click More Info and click Run anyway. FreeCAD should load. It will ask you to select a language, unit system, navigation style, and theme. Pick your language and leave the unit system at the default metric system. For navigation, I really like TinkerCAD style, as I find it to be very intuitive, so I recommend using that. I'll also show you how to change these later. Select a theme, if you wish, and then click Done. Like most modern graphical interfaces, it will try to suggest what to do next. I recommend just ignoring these suggestions, as I'll walk you through the process of creating documents and parts from scratch. I mentioned earlier that FreeCAD is a collection of workbenches. A workbench is, in turn, a collection of tools, buttons, and interface options. FreeCAD, by default, puts us in the part design workbench, which is the recommended workflow for newcomers to create 3D designs. Take note of the buttons and menu options. We'll slowly go over most of these in the coming episodes, but just pay attention to what happens when we switch workbenches. In the top bar of FreeCAD, you will find the Workbench Selection menu. Click to drop it down to see the various workbench options. These are the default workbenches that come with FreeCAD, and you can install third-party workbenches, which I'll demonstrate in later episodes. There's a lot here, so this can be somewhat overwhelming. If I click on Part, you'll notice that the buttons and menu options change as I have switched over to the Part workbench. Part is just another way to create 3D objects. It was added in the early days of FreeCAD before part design, so it's often considered the legacy or old school workflow, but it still has some uses. It relies on the older constructive solid geometry method, which involves adding and subtracting simple shapes like cubes and spheres. To create more complex parts, Sketcher is another popular workbench used to make 2D drawings that can be used in 3D designs. For the majority of this series, we'll focus on two workbenches, Part Design and Sketcher. These workbenches operate in tandem to help you create 3D objects. In later episodes, when we start making more advanced shapes or putting parts together in assemblies, we'll explore other workbenches. For now, select the Part Design workbench. Click on the New Document button. This creates a document object in the tree view on the left side. A document can store multiple parts, containers, bare sketches, and so on. When you save your work, everything under this document object gets saved as a single FreeCAD project file. You can have multiple documents open at once, but I usually prefer to close all but the one I'm working on to keep this tree view clean. Notice that I can click on a document to activate it, and the title will become bold. You can right-click on a document and select Close Document to remove it from the workspace. Click Create Body. You can also find this command under the Part Design menu option. This creates a body object in the current document. In the Part Design workflow, a body is a collection of operations needed to create a single, contiguous shape of any complexity. We'll create a simple design in a body in the next episode. Notice that the body is highlighted with light purple. That means this body is the active body in the document. When I create sketches or features, they get applied to the current active body. If I add another body, the new one will become the active body. In a couple of episodes, we'll start working with multiple bodies in the same document, so it's useful to know how to switch between active bodies. Right-click on the non-active body and select Active Body to switch to work on that body. Notice that we have an origin under the body that is grayed out. That means that particular object is hidden from the main 3D view. Right-click on Origin and select Toggle Visibility. You can also select the origin object and press the spacebar. You should see a set of axes and planes appear in the main view. Note that the body and the feature or object must be set to visible to see them in the viewer. If I hide the body with the origin visible, the origin and anything else under that body will disappear. This continues to bite me to this day. If something isn't showing up in the viewer, make sure that both the body and the feature are both set to visible. Right-click on the second body you created and select Delete. You can also press the Delete key. Most objects and features you see in the tree view can be deleted this way. Right-click somewhere in the viewer and move your mouse around while holding down the right mouse button. This allows you to rotate the view, which is incredibly useful when making 3D parts. The little red dot that appears shows you where you clicked, and the camera will rotate around that point. If you hold the middle mouse button and drag the mouse, the camera will pan. You can also zoom with the mouse wheel. This combination of rotate, pan, and zoom is all you need to set your camera to any angle and position. If you do not like this control scheme, go to Edit, Preferences. Notice that in general, you can set the unit system should you need to change the default for FreeCAD. Make sure it's set to metric, as that's what we'll use for most of this course. In my experience, you usually need to restart FreeCAD after setting the unit system. Go to Display, Navigation. Click the drop-down menu by 3D Navigation. These are the available schemes. I happen to like the TinkerCAD style, so I'll leave it at that. It's similar to the navigation scheme in my slicer program, but sometimes if I'm working on my laptop with no mouse, I'll switch it over to touchpad. Click the mouse button to see the scheme. Close out of those menus. You can left-click to select parts, faces, and lines in the viewer. This will be necessary when we start manipulating sketches and features later. In the top right, you'll find the navigation cube. You can click on various parts of the cube to set the camera to view that particular face. This includes edges and corners as well. The arrows let you rotate the camera 45 degrees in that particular direction. The little cube icon gives you the option to change the perspective. You can also find these options in the View menu. Orthographic is the normal view style for most CAD programs. There is no perspective, so objects farther away appear to be the same size as those closer to the camera. This is very helpful when trying to line up different features in a 3D shape. If you'd like to enable perspective, you can click on the perspective view. This can be useful to see how an object might look in real life, but usually I leave it off when designing parts. The very basic flow of part design is to create a two-dimensional sketch and then create a three-dimensional feature from that sketch. As I showed in the topological naming problem demonstration, we first click on a sketch. Below the tree view pane, you should see the tasks pane change and ask you where to place the sketch. Notice that most of the workbench buttons are grayed out. If you ever notice that you can't do something in a workbench, first check to see if there's something in the tasks pane. Either finish the task or click cancel, and the buttons should no longer be grayed out. This also continues to bite me. For now, let's create a sketch and click on the XY plane. Note that you can either select the plane in the tasks pane or in the viewer. If you select it in the viewer will rotate to face that plane. Also, notice that the workbench automatically changes to Sketcher, and our buttons are now different. From here, we can create a basic shape, like a rectangle. Click the Create Rectangle button and draw the shape anywhere in the main view. Notice the rectangle icon by our mouse cursor. This shows that we're still in the Create Rectangle tool mode. Either right-click or press the Escape key to exit the tool. For a normal design, you'd want to define the dimensions or set the constraints of this sketch before moving on. We'll cover that in the next episode. For now, just click Close in the Tasks pane. Notice that we return to the Part Design workbench. With the sketch selected in the tree view, click the Pad button. This has the same effect as creating an extrusion from our sketch. Leave the default parameters and click OK. In the viewer, you should see that we've created a very simple box out of our sketch. In the tree view, you can expand the pad operation to see our sketch. In Part Design, we create a set of operations or features that are computed in chronological order to make up a single, contiguous body. Don't worry if that didn't make much sense right now. You'll get a feel for it as we start making parts later. If you double-click the sketch, you can edit it. Now, if I drag one of the sides to be longer and click Close, you'll see that the pad operation automatically updated with my sketch. This is the basics of parametric modeling. We can set parameters in our sketches or 3D features, and the system will automatically update when we change those parameters. We'll dive more into this later. Don't worry about saving this document. I just wanted to show you the basics of the part design workflow so that you're somewhat familiar with it for the next video. I hope this helped you understand a little about the various CAD offerings and how to somewhat navigate in FreeCAD. In the next episode, we'll actually make our first part, and I'll give you a fun challenge at the end. Stay tuned.